So now that we're certified experts on finding restrictions, they're going to start turning up the complexity on us. This is all factored, which is nice. So all I have to do to execute the division is I'm going to change this to a times. I'm going to flip the second fraction over. So the first thing doesn't change. The division becomes a multiplication, and then the second fraction is written upside down. And now, switch to red. Can we cancel anything? We've got x plus 1s. Drop those. We have x plus 3s. And that appears to be it. So our finished version should be x over x minus 2. That's our simplified form. Now, what do we have for denominators for restrictions? From the original, x minus 2, that tells us x can't equal 2. Takes care of that piece. X plus 3 tells us that x can't be negative 3. X, that tells us x can't be 0. X plus 3, well, never mind, we have that already. We don't need to write it twice just because it appears twice. So that's all our non-permissibles from the first expression. Then we flip this over, and now we get a new thing. We get x plus 1 in the denominator now. That gives us one more non-permissible value. X also can't be negative 1. So all 4 of these are the restrictions on the variable. Now, this is rather nasty. The way I try to see this is as a fraction divided by, great big horizontal line, another fraction. In other words, this is the same as 4x plus 12 over 3x plus 12 divided by the thing downstairs, 3x squared plus 9x over x plus 4 all squared. We don't do this transformation often enough, I don't think, but it's very important. Anytime you have a fraction, top thing over bottom thing, that means the top thing divided by the bottom thing. 2/3 means 2 divided by 3, and in this case, the thing with all the 12s in it is divided by the thing with the 3x squared in it. So this is an improvement. We went from having a 4-level fraction, which is scary stuff, to a couple of 2-level fractions. And the next thing we can do is where this division used to be, I'm going to put a times, and then this second fraction is getting flipped upside down. So 4x plus 12 over 3x plus 12 times x plus 4 squared over 3x squared plus 9x. There we go. The division is dealt with. We've still got 2-level fractions, which isn't so bad. Now, if we want to simplify this, we're going to factor everything and hope that we get some factors which cancel out. So from this first top left piece, I can factor out a common factor of 4. That leaves us with x plus 3. Do these kind of fast. 3 out of the bottom left piece leaves us with x plus 4. Here we have x plus 4 all squared. And in the bottom right, common factor of 3x leaves us with x plus 3. Can we cancel anything? Yes, we can. X plus 3's drop out. X plus, whoops, didn't mean to do that. We can cancel this x plus 4. We can cancel one of the x plus 4's. The other one still survives in the numerator. So we're left with 4x plus 4 over 3 times 3 is 9x. That's probably the nicest way to write this. You could take the 4/9 out if you wanted and have 4/9 x plus 4 over x. I'm not sure that's nicer, but it is another possibility. Now, non-permissibles. Our denominators in this thing have been, well, we have 3x plus 12 Sorry, that's too light. We have 3x plus 12, which can't equal 0. That leads to x can't be negative 4. So that's a denominator. We had x plus 4 here, which gives us x can't be negative 4. We knew that already. We have this flipped version where 3x squared plus 9x is in the denominator. In other words, this is in the denominator. I'll use the factored form. From the 3x, we get x can't equal 0. From the x plus 3, we get x can't equal negative 3. X plus 4, we got that already. I'm just checking all the denominators to make sure we didn't miss anything. X plus 4, we got it. That should be it. That's all our non-permissibles.